Good evening, ladies and gentlemen, boys and girls, friends and neighbors, or good morning, whatever the case may be. Not sure when you watch these videos. We're just really hoping that you are indeed watching the videos. And video number 1 for Unit 10, Lesson 2. I should have watched that maybe yesterday, but Unit 10, Lesson 2, Video 1. What did Video 1 do? Video number 1 gave the proof for this guy right here. And as soon as I prove that, the other formula can flow right from that proof. And this was a long drawn out proof. That proof should have gone on a blank paper in your interactive notebook with, of course, your name on the top of that. This particular video is going to be right in your interactive notes page, your examples for Unit 10, Lesson 2. And again, you are going to put your name. That was kind of freaky. You are going to put your name on the heading when you take a picture of these particular notes for all the pages. So today in video 2, what I'm going to do is I'm not going to do the proof. I'm just going to do some applications of using these formulas right here. The application. And here I have a cosine of A plus B, which is equal to cosine of A, cosine of B minus sine of A and sine of B. And you might be wondering, as I'm sure a lot of students do, where do we use these at? Cosine of A minus B is cosine of A, cosine of B plus sine of A, sine of B. Well, here's how we do these problems. Why does that keep changing colors? I didn't know, but it's kind of freaking. It is freaking me out. Well, it doesn't matter. Okay, so what I want to do is I'm going to use the above identities. I'm going to start off with degrees to make it easier. And I'm going to find the exact value. I'm going to need to know the exact value of special angles. We'll know that. And what I want to do is I want to find the exact value of cosine of 75. Hey, you have your graphing calculator. You have your calculator on phone. I can estimate the cosine of 75. Okay? And for most general purposes, this estimation is going to be very nice. But we need to know how to apply these formulas for next year. So what we're going to do is we're going to apply this particular formula, and we're going to use our knowledge of the unit circle. The first thing I want you to realize is that 75 is 45 plus 30. True or false? So therefore, 75 is 45 plus 30. 40, I'm going to use the sum formula for cosine. And this particular formula just comes from up here. It's the blue one. Cosine of A plus B is the cosine of A, cosine of B minus sine of A, sine of B. All right. And what I'm going to do is I'm going to write cosine of 75 as the cosine of 45 plus 30. And by the formula, then, this is going to be cosine of 45 times cosine of 30 minus sine of 45 times the sine of 30 by this formula. This is the formula that we're applying, that we're using. And now, look at this, ladies and gentlemen. I know the exact value of this. I know the exact value of this by the unit circle. I know the exact value of this. I know the exact value of this. So what is the cosine of 45 degrees? The cosine of 45 degrees, what is that? This is going to be the square root, write it in red, 2 over 2. And what's the cosine of 30 degrees? The cosine of 30 degrees, using your unit circle, is the square root of 3 over 2. Hey, what's the sine of 45 degrees? That's the square root of 2 over 2. Hey, what's the sine of 30? 1/2. So what is the exact value of cosine 75? The exact value then simplifying these radicals, square root of 2 times square root of 3 is square root of 6, over 2 times 2 is 4, minus the square root of 2 over 4. Okay, looks kind of freaky, but this, guess what this is? This is an approximation for 9659. This is the exact value. This is the approximation of cosine of 75. Okay, so now we're going to do an example where the degrees are in radians, and that's okay. And we're going to note here, we're going to try to figure out what the exact value of cosine of pi over 12 is. And notice, true or false, pi over 12 is not one of those nice angles on the unit circle. The nice angles on the unit circle are, well, 1/6, 1/4, 1/3, 1/2. All the multiples of 1/6, all the multiples of 1/4, ... 12th isn't on there. But guess what we can do? Pi over 12, and here comes the trick. This is the trick, is using two angles that we know on the unit circle that either add up to the desired angle, which is in this case pi over 12, or subtract. In this, true or false, get that out of there. True or false, 3 pi over 12 minus 2 pi over 12 is indeed pi over 12. Well, what is 3 pi over 12? That's the same as pi over 4, a nice angle on the unit circle. What's 2 pi over 12? Pi over 6, again, a nice angle on the unit circle. So I'm going to write cosine of pi over 12. I'm going to write that as cosine of pi over 4 minus pi over 6. And now I'm going to implore this particular formula up here. Since I have the difference of two angles, I'm going to implore this particular formula. Cosine of A, cosine of B. So it's going to be the cosine of the first angle. Cosine of the first angle, pi over 4, times cosine of the second angle. And now, is this a plus or a minus? Well, this is a minus, so this must be a no. If you're taking the cosine of the difference of two angles, you're going to add the product of the cosines and the product of the sines. So the cosine of A minus B is cosine of A, cosine of B, plus sine of A, sine of B. And this is what we proved yesterday. This formula was given without proof. So this is the one we're going to use. We're adding the product of the cosines to the product of the sine of the angles. This is just an application, ladies and gentlemen. Just an application, so we can get an exact value for this dude, cosine of pi over 12. Hey, well, true or false? This is square root of 2 over 2. Cosine of pi over 6. Again, it's the same thing we had up there, but only in radians. Cosine of pi over 6 is square root of 3 over 2. Plus, only this time we're adding square root of 2 over 2 times 1/2. And what does that equal? This is going to be the square root of 6 over 4 plus the square root of 2 over 4. And this, ladies and gentlemen, this is the exact value of the cosine of pi over 12. Very nicely done. I hope you can see the application of these two formulas. Alrighty. Oh, here's a nice one. Cosine of pi over 2 minus A. This is already given. What I want to do is I'm going to prove an identity that we've been talking about. And let's see what this is equal. And I'm going to use the difference formula for those cosine of A minus B. So this is going to equal, true or false? Whoa! True or false? This is going to equal cosine of pi over 2 times the cosine of A. If I'm subtracting two angles, then I'm going to add the product of the cosines 2, product of the sines. This is going to be a nice little proof you're going to see here. Okay, hey, what's the cosine of pi over 2? The cosine of pi over 2, ladies and gentlemen, is 0. This rascal right here is 0. And 0 times cosine of A, we know what that is. That's going to be a big giant 0. What's the sine of pi over 2? Oh, that's 1. 1 times the sine of A. And what's 0 plus the sine of A? Oh, that's nice. That's the sine of A. And we've talked about this identity before. This is an identity. We talked about it last unit, but this is just another little verification of this particular identity. If I have the cosine of 90 degrees, or pi over 2 minus A, ladies and gentlemen, that's just the sine of A. And now I can use the difference formula for angles with the cosine and show that. What I'm going to do now is flip back a page in my interactive notebook, and I'm going to go to the page that talks about the formulas for the sine of the sum of an angle and the sine of the difference of an angle. Okie dokie. So I have the sine of A plus B. Sine of A cosine of B plus cosine of A sine of B. And again, this is given without proof. No proof given. This is I believe. This is going to have to be I believe. I'm just going to believe this. I believe, brother. I believe, brother. Now you could, there is a proof for this, but it is long and drawn out. And what we're going to do is we're just going to apply this particular formula that we're going to say, hey, I believe. I believe. Alrighty. I believe, brother. All right. Sine of 105. Give me the exact value of the sine of 105. Oh, the hint is 105, ladies and gentlemen, is 45 plus 60. So I'm going to write this, ladies and gentlemen, the sine of 105. I'm going to write that as the sine of 45 plus 60. And now I'm going to use this particular formula. Make sure that you're on the right formula because I'm adding the angle. So this is going to equal. And it changes now. This is different than the cosine. The cosine of the sum of the angles was cosine, cosine, sine, sine. This one is sine, cosine, cosine, sine. So this rascal going to have to be very careful. This is going to be the sine of 45 degrees. Sine of the first angle times cosine of the second plus sine of the second pardon me, I'm going to write it as it's given up there. It's going to be the cosine of the first, so it's going to be cosine of 45. It wouldn't have mattered order, but I'm just going to follow this formula. So it's going to be sine of the first, cosine of the second, cosine of the first, sine of the second. Just keep some order to things. Okay, well, I know what the sine of 45 is. By the unit circle, I know that this is square root of 2 over 2. And I know the cosine of 60 is square root of 3 over 2. Boy, it comes to these values come up a lot on our examples. Yes, in the assignment, they won't be this clean, won't be this nice. But this is still a good example for what we're doing here. The cosine of 45 is square root of 2 over 2. We know that. And the sine of 60 is this right here. Hello there, Roy. This one right here is 1/2 right here. Alrighty. And so what does this equal? Take a pausing a minute. Square root of 2 over 4 plus the square root of 6 over 4. All right. We're going to do one more example, and you will have some examples to write in your notebook there. Let's do this guy. All right. Sine of 11/12. Again, this 11/12 is not a pretty angle on the unit circle. That's okay, because we know 11/12 is equal to 8/12 plus 3/12. Well, ladies and gentlemen, what is 8/12? 8/12, true or false, that's equal to, if I factor a 4 out, that's 4/3 pi. That's a nice angle on the unit circle. And what's 3 divided by 12? That's going to be 1/4 pi. So those two angles are nice angles on the unit circle. I'm going to write this guy right here if I want to find the exact value of 11/12 pi. That rascal is going to be the sine of 4/3 pi plus pi over 4. And I'm going to use the formula because I know these nice angles. This is going to be sine, cosine, first angle, cosine of second angle, plus cosine of first angle, sine of second angle. And I'm going to let you figure out what those are. And we are going to have some more examples of this on the next video. So there will be a video number 3 over this lesson because this is kind of a tough lesson. We had a tough little proof, so we're going to end this video. And I will let you figure out what this is on your own. We know what this value, you can figure out what this value is, unit circle, this value, unit circle, this value, unit circle, this value, unit circle. And we will do problems like this on video number 3 for this week. Alrighty, well, thank you. 18 minutes, and we are 1, 2, 3.